A landing gear undercarriage supports the weight of an aircraft during taxi, takeoff, and landing rule, and while parked on the run for the purpose of the embarkation and disembarkation of the passengers, loading and offloading the cargo and luggage. Except for the small models of the aircraft which are equipped with a fixed landing gear system, almost all medium to large transport category aircrafts are equipped with the retractable landing gear system. So a retractable landing gear is such a landing gear which after takeoff the pilots retract them inside of the housing, because we do not need them to be extended in the whole range of the flight. And besides, if we let the landing gears to remain extended, the aircraft cannot gain speed and we cannot fly higher altitude. And besides, the rate of the fuel flow will be excessive because they will create plenty of the drag. For the designers and manufacturers of the landing gears, when they are planning to design landing gear for a new model of the aircraft, different challenges and different problems are there that they should think about. The three main characteristics of each and every landing gear are that the landing gears should have the rigidity, they should have flexibility, and they should have the shock absorbing characteristic. So when the landing gears are fully down and locked, we need them to be rigid enough. So there should not be any single degree of the play in the landing gear linkages. And then after takeoff, you need to break down this rigidity and change the landing gear into a flexible unit and retract it inside of the housing. And mostly during the landing, because all landings are not successful to have a textbook landing. Mostly there is shock when the aircraft touches on the runway, so the landing gear should be able to absorb this shock or absorb this force without transferring to the other linkages and mechanisms where the landing gear is attached in the fuselage or maybe in the wing. And besides, the landing gear should have a mechanism to absorb this shock without bringing any damage or deformation to its own linkages. Regarding the number of the wheels attached to the landing gear, it differs from one aircraft model to another. Mostly in medium body aircraft, we have conventional two-wheel landing gears, mainly in the main landing gears left and right. But as much as the fuselage extends and as much as the fuselage becomes larger, more number of the wheels are required to be attached in the landing gear, mainly in the main landing gears, because we need the force to be distributed between the wheels, and besides, more wheels will support the weight of the aircraft. And regarding the performance calculation, so when the weight is distributed amongst the more number of the wheels, we can have better range of the center of gravity or the CG of the aircraft. So we can have, for example, 4 wheels, we can have 6 wheels attached in the main landing gears. In most large aircrafts, they are having a landing gear in the middle of the fuselage. This is because we need more wheels and more landing gears to support the weight of the aircraft. When a landing gear is designed before it is released for the service or for the to be attached in the fuselage or the wing of an aircraft, different other tests should be performed on the landing gear, just for the manufacturer to make sure that the landing gears are capable of absorbing different shocks and stresses without being damaged and deformed. One main test which is performed on the landing gear is the drop test. So the drop test, the landing gear structure is attached to a machine or mechanism, and then the machine brings the landing gear down on a surface, and then the amount of the force which are brought to the landing gear is calculated, and the manufacturers wants to make sure that there is not any damage or deformation on the linkages and the main structure of the landing gear, in fact, besides other tests. Then when the landing gear is released for the service, the manufacturer assigns a limit for the serviceability of the landing gear. This limit is based on the number of the cycles and based on the calendar month that is passed on the landing gear. So mainly in Boeing 737 classics, the number of the cycles is 12,000. This means that when the landing gear is attached to the aircraft can have 12,000 landings with this landing gear. In fact, if between 12,000 cycles there is a damage or maybe some hard landings or any other problems, that's another story, that the landing gear should be removed and sent back for the overhaul. Otherwise, if everything goes fine, then the aircraft can have 12,000 landings with that newly manufactured or overhauled landing gear. And besides, there is for example, calendar month period on the landing gear as well. Mostly 8 years or roughly 10 years is assigned for the landing gear. Let's say, for example, landing gear is attached to an aircraft, and then after some flights, the aircraft is prolonged parked without being in flight and in service. So when 8 years or roughly 10 years is passed on the aircraft, the landing gear is going to be no more serviceable and it should be removed and sent for the overhaul. Hardly we can find mostly in used aircrafts that the 3 or 4 landing gears attached have the same number of the cycles or same number of the calendar month. Because it differs from the time when the landing gear was sent for the overhaul or for the complete test. So it is usual to have an aircraft, for example, with a left main landing gear having 8,000 cycles, and with the right main landing gear having 3,000 cycles, and nose landing gear having, let's say, 1,000 cycles. This is normal. But once the number of the cycles is completed, then the airline should remove the whole structure of the landing gear, replace it with a new one, and the old one should be sent to an MRO for the overhaul. So what does the MRO do? The MRO will test and check all the linkages and main structure of the landing gear based on the rules which is released from the landing gear manufacturer. So they will remove the paint and coating, and they will see if there is any fine crack in the structure of the landing gear. Then there are some linkages that they should be for example, tested, and to see about the wear, about the lifetime of those linkages. They should be replaced with the new ones, and then the landing gear is going to be released back to service with a assigned number of the cycles or calendar month. The main structure of a landing gear is the shock strut, or which is also called shock absorber unit of the landing gear. So in this unit, if we look at inside, we have a metric valve, and then we have a metric pin. Out structure is the cylinder, and then inside we have a piston. So the piston should be extended from the cylinder. Inside of the cylinder we have hydraulics and compressed air. Because the weight of hydraulic is more, the hydraulic will sink down and above to the top of the shock absorber or shock strut. We have compressed air. The air which should be charged inside of the shock strut should be dry nitrogen. So normal air which is got from the surrounding should not be charged inside, because if we charge the air with some moisture inside during cold weather operations, we will get problem with the shock absorbing mechanism of the landing gear. So dry nitrogen should be charged inside. That's a compressed air which is at the top of the shock strut. So once the aircraft touches on the runway, then the piston is forced inside of the cylinder. So the metric pin which drives inside of the metric valve restricts the flow of the hydraulic from downside to the upside, and besides, the compressed air at the top of the shock absorber or the shock strut will just absorb the shock. But if the landing is so hard and the landing is very, for example, with a very high impact, so the characteristic of the shock absorbing of the landing gear will be reached to a limit, and then the landing gear will so the linkages will be damaged, and mostly in some very hard landings, it has been seen that even the structure where the landing gear is attached is for example, got some problems, some deformation, and also this is some sort of the landing that should truly be inspected, and even sometimes the landing gear should be removed and sent back for the overhaul and replaced with a new one. The power to extend and retract the landing gear is from one of the hydraulic sources of the aircraft. Because landing gear is very heavy, we have wheels attached, we have brakes attached to the landing gear. So because of the heavy weight, the only source of the power that can extend and retract the landing gear is one of the sources of hydraulics from the main hydraulic system. For example, in 737 Classics, we use hydraulic system A to retract and extend the landing gear. This is the normal system. And then if hydraulic system A is not available, then after takeoff we cannot retract the landing gears and they will remain extended. But during the flight, when the landing gears are fully retracted and locked and we lose hydraulic system A, we have alternate system to extend the landing gears, and that is the manual gear extension system. So later we will look at it, how it works, and when the pilots can use it. Once the landing gears are retracted, we have mechanical locks, and the mechanical locks will lock the landing gears in the up position, and we do not need hydraulic pressure continuously to be applied on the landing gear to keep them up and locked. So once they are retracted and locked, we can relieve the hydraulic pressure on the landing gear system on the lines, and they will remain retracted with the up lock mechanism. Same way, when we extend the landing gears, once they are fully extended and locked, then the down lock mechanism will engage, and they will keep the landing gears in the down and locked position. But for the safety purposes, once the landing gears are fully down and locked, we still need the hydraulic pressure to be applied on the down line of the landing gears, as long as the hydraulic pressure is available up to the touchdown and landing rule. Besides the shock absorber mechanism or shock strut, which is the main structure of the landing gear, mostly we have some other linkages which support the rigidity of the landing gear. So it supports the landing gear to be rigid without having single play. Mostly in Classics we have two other linkages, which are the drag strut and the side strut. So the side strut prevents the landing gear from moving to the side, mainly in the main landing gear, and then drag strut prevents the landing gear to be moved backwards and prevent the landing gear from the collapse, in fact after landing and mostly during the takeoff and landing rule. In the cockpit, we have a landing gear lever, which is in the front instrument panel, and the landing gear lever has three positions. It has down position, then it has off position in the center, and then it has up position in the up side of the lever. And above the lever we have 6 indicator lights. Landing gear lever is put to the down position. Hydraulic pressure from system A is supplied to the landing gears actuators, but we have a selector valve there. Before the hydraulic pressure moves to the actuator to extend the landing gears, the selector valve first supplies hydraulic pressure to the up lock mechanism, and the up lock mechanism will be just move to unlock the landing gears from up position. And then when the selector valve makes sure that the up lock mechanism is unlocked, then hydraulic pressure will be directed to the actuator, and the piston will retract. When the piston retracts, landing gear will be free fall and will move down by 3 forces. In fact, by hydraulic force, then by its own weight, and then by the air force. And the landing gears will come down, and then hydraulic pressure will be supplied to the down lock mechanism, and the mechanism will apply, and then landing gears will be down and locked for the purpose of the landing. The off position of the lever relieves the hydraulic pressure from the landing gear system. So when we move the lever to the off position, that's after the takeoff. After takeoff, when the lever is moved from down to off and from off to up, then same way the hydraulic pressure from system A will be supplied to the actuators to retract the landing gears. But before the hydraulic pressure is supplied to the actuators, the selector valve first supplies hydraulic pressure to the downlock mechanism, and the downlock mechanism should be unlocked. When the selector valve makes sure that the downlocks are disengaged or unlocked, then hydraulic pressure will be supplied to the actuator. This way, in the actuator, the piston will extend, and then the mechanism will cause the landing gears to be retracted. And once the retraction cycle is completed, then the uplock mechanism will engage and lock the landing gears in the up position. And after the retraction cycle is completed, and then we move the landing gear lever from up to the off position, because as we stated before, we do not need the hydraulic pressure continuously to be applied on the landing gear system or mechanism or the actuator, because now we are sure that the landing gears are fully up, and uplock just keeps the landing gears in the up position. In Class 6, the left main landing gear will be retracted towards the right inside of the main wheel well, and the right main landing gear will be retracted towards the left inside of the main wheel well, and the nose landing gear will be retracted forward inside of the nose structure. So for the nose landing gears, we have two wheel well doors which are mechanically attached to the structure of the nose landing gear. So once the nose landing gear is fully up and locked, then the doors will mechanically close to make it streamlined for the airflow. And then for the main landing gears, we have small wheel well doors which are also mechanically attached to the structure of the main landing gears, and when the gears are retracted, the doors will close. If you look at the wheels and 737 Class 6, we have caps, and wheel number 1 and wheel number 4. We have only two caps. So these caps are that with when the landing gears or the wheels are fully retracted, then they will make streamline, because the caps will be visible from the outside, and the caps are there just to make the structure streamline for the airflow, not to create any drag. To taxi the aircraft on the ground, the nose landing gear is equipped with a steering mechanism. We have two actuators attached to the nose landing gear, which are just supplied by the hydraulic pressure from the system A. So normally we need hydraulic system A to steer the aircraft on the ground. In case hydraulic system A is not available, then by using the steering switch, we can supply hydraulic system B to the nose landing gear just to have the steering system available. Normally the aircraft is steered on the ground by a steering wheel which is attached in the left side, and the captain only can steer the aircraft because we do not have the steering wheel available for the first officer. By using the steering wheel, the captain can steer the aircraft to the maximum of 78 degrees on the ground, but mostly during the straightforward taxiing or taxi routes, we can steer the aircraft by use of the rudder pedals as well, but that steering degree is limited to 7 degrees. More than 7 degrees we cannot steer. So pilots should be cautioned, especially the captains, when they are using the steering by the rudder pedals, because short turns cannot be performed by use of the rudder pedals, and steering wheel should be used. The retraction and extension system of the nose landing gear is also performed by hydraulic system A. So during the retraction cycle, when the landing gear lever is moved to the up position, then hydraulic system A is supplied to the selector valve, and selector valve first feeds the hydraulic pressure to the down-lock mechanism, and once down-lock mechanism is unlocked, then the selector valve will send the hydraulic pressure to the actuator, and the nose landing gear will be retracted forward inside of the nose structure. Once the retraction cycle is completed, then we have an over-center mechanism, and the over-center mechanism will keep the nose landing gear up and locked. Then, since we do not have brakes available in the nose landing gear, so after takeoff, the wheels or the nose wheels will continue rotation. So how to stop this rotation? And then we have two snubbers attached at the ceiling of the nose wheel well, so the nose wheels will attach to the snubbers and the rotation will be stopped. Mostly we have some vibrations on the nose landing gear, even though we have a shimi damper system available, and the nose landing gear and the shimi damper system absorb the shimmying of the nose landing gear, but mostly because of the high speed turns on the ground, some more stress is brought to one side of the wheel, and that wheel will be a little bit worn than the opposite wheel, and it will cause some vibrations during the taxi, and this vibration is mostly felt during the slow speeds during the taxi, during the takeoff and landing rule as well. Another cause of the vibration on the nose landing gear is because of the imbalance of the wheels. For example, if one wheel is not better balanced than the opposite wheel, that will also cause the vibrations on the nose landing gear. In case the hydraulic system A is not available during the flight, so the nose landing gear is also equipped with the manual extension mechanism or system. So we have three levers attached to a panel, which is the back side of the first officer seat, and the center lever is for the nose landing gear. So based on the non-normal checklist and procedures, we need the hydraulic system A to be depressurized completely, and then we put the landing gear lever to the off position, and it should be in the off position, and extending the center lever and the cable up to the limit will disengage the uplock mechanism, and then the nose landing gear will free fall by its own weight and ear load, and it will come down, and the downlock mechanism automatically will engage, and then the nose landing gear is ready for the landing. Coming to the main landing gears, we have two main landing gears in Boeing 737 Classics, mainly left main landing gear and the right main landing gear. And the main structure of the main landing gear is, as we said before, the shock absorbing mechanism, or the shock absorber, or the shock strut, in other words. So same as we explained before, we have a metering valve and metering pin, which is inside of the shock absorber or shock strut, and then the shock strut is charged with the hydraulics and compressed here, in fact the dry nitrogen, to absorb the shock of the impact or landing. And then we have two other struts, which are the drag strut and the side strut, which support the landing gear to be rigid enough without having single degree of the play when it is down and locked. The actuator for the extension and retraction of the main landing gear is powered by the hydraulic system A. As we explained before, when the main landing gear is fully down and locked, so the down lock is engaged. Once the landing gear lever is moved from down to off and then from off to up, then the selector valve will direct hydraulic pressure from the system A to unlock the landing gear, and then once the landing gear is unlocked from the down position, then hydraulic pressure will be supplied to the actuator, and the actuator will retract the main landing gear, and the left main landing gear will be retracted towards the right, and the right main landing gear will be retracted towards the left inside of the wheel well. Once the landing gears are fully retracted, uplock mechanism will engage and will lock them in the up position. Then the landing gear lever can be brought to the off position just to relieve the hydraulic pressure on the landing gear system or mechanism or tubes, in fact. During flight, if we lose hydraulic system A, so we have a manual gear extension mechanism, same as we explained for the nose landing gear. So still on the panel, which is at the back side of the first officer seat, the left lever is for the left main gear, and the right lever is for the right main gear. So extending any lever or pulling the lever up to the limit will uplock the or unlock the uplock mechanism. When the uplock mechanism is unlocked, the main landing gear will free fall by its own weight and air load, and then the downlock will be engaged. Landing gear will be ready for the landing. It's fully down and locked. Another important unit which is attached in the main landing gears is a shimi damper system. So the shimi damper system consists of a cylinder and piston inside, and this unit just absorbs the shimmying of the main landing gears after landing and during the for example landing rule or during the takeoff rule, because we need the rudder pedals to just keep the aircraft in the center line of the runway. In fact, some side-to-side shimmying or movement will be brought to the landing gear, so the shimi damper system absorbs this shock. And if the force is brought to the left, then the piston will extend to the left in order to absorb the shock and limit it to be on the landing gear. And the forces applied to the right, the piston will extend to the right in order to just absorb this shimmying towards the right. Because the shimi damper of the main landing gears needs lubrication, lubricant liquid to be always inside, because we have some mechanical linkages. So a line is just brought from the main oil tank of the aircraft to this shimi damper unit, which will supply the lubricant fluid continuously in case there is a leakage. So the chance of breakage of the shimi damper is excessive. In order to prevent this, then the line will bring the lubricant oil from the main oil tank of the aircraft to this unit in order to keep it lubricated continuously. So in fact, after landing, the just engineers and mechanics having a walk around and inspection on the aircraft will find out that the unit is leaking and the oil is dropping from the shimi damper. That's the time that the shimi damper should be replaced completely. For all landing gears, mainly the main left, main right, and nose, we have some markings and drawings which ensures that the landing gears are fully down and locked. So when these markings are viewed, let's say during the flight, if it gets problem with the landing gear and we are manually extending them and we do not get the proper lights on the above the landing gear lever, we have some viewing ports which the pilots or maybe mechanics on board the aircraft can look on the viewing port, and to make sure those lines, red lines, are aligned. So alignment of those three strips, in fact in the main landing gear we have 3 red strips. When these 3 red strips are aligned, this means the landing gear is fully down and locked. And for the nose landing gear we have 2 arrows, and when these 2 red arrows are aligned, this means the nose landing gear is also fully down and locked. And the viewing port for the nose landing gear is in the cockpit, just past the cockpit door, and then the viewing port for the main landing gears are inside of the cabin. During the any usual inspection and checks of the aircraft, the ground personnel should make sure that the viewing ports are not greasy, the viewing ports are not dirty, and they should make sure that the viewing ports are clean enough to let the pilots have better view of the lock mechanism, down lock mechanism of the landing gears when they view from the cockpit for the nose landing gear, or view from the cabin for the main landing gears. Besides, that's also very important during the exterior walk around just before the flight. that we should make sure that the main wheel well and the nose wheel well lights are operational, especially during the night flights, because during the night, if you get problem with the landing gear system and we just want to view from the viewing ports to make sure the landing gears are either fully down, unlocked or not, so we need to turn on the main wheel well lights and the nose wheel well light just to have a better view of the just those markings to make sure the landing gears are fully down and locked. Research from the landing gear manufacturers indicates that one enemy of the landing gear linkages is the smooth landing. Mainly Boeing families do not recommend any smooth landing for the pilots, and we cannot find a smooth landing wording in any of the manuals of the Boeing. So all the landings should be on the touchdown point, and then we should just have a firm landing. So firm landing means that we should touch on the runway. We should not try to have a smooth landings. Mostly just pilots are trying to have the smooth landing by having excess power when they come for the landing, mostly after the 10 feet, or they have the long flaring maneuver just to have a very smooth touchdown and landing on the runway. That recent research shows that one smooth landing wears the linkages of the landing gear like the 50%, like means that if one smooth landing means we have made 50 landings on the landing gear. So that's not recommended, and all landings should be firm, and all landings should be with a small amount of the touch on the just runway. So if we make a firm touchdown, all the linkages of the landing gears will feel that they are on the ground and they will be functioning properly. Another main cause of the shimi damper breakage or problem on the main landing gear, mainly in Boeing 737 Classics, because if you look at the history of the Boeing 737 Classics, we have plenty of the events and plenty of the incidents that the main landing gear shimi has been broken down. So once the shimi is broken down, the landing gear will be free, so the piston inside of the cylinder will be free to move. It's not going to be kept straight ahead, so that will cause the landing gear to have excess vibration, and excess vibration mostly causes the landing gear to be damaged, to the linkages to be broken down, and the landing gear will collapse. So please look at the story of the Boeing 737 Classics and you can find plenty of such events. One cause of the shimi damper breakage or the failure in the main landing gear is smooth landing, because after takeoff, so the piston is free to move out from the cylinder, I mean is in the shock strut, so the piston will extend up, the piston will extend out, so the amount of the extension is limited by the shimi damper, because we have two linkages attached to the up and down side of the shimi damper. The up link is connected to the fixed part of the landing gear, which is the cylinder, and then the down linkage is connected to the movable side of the landing gear, which is the piston. So it limits the extension of the piston to be extended from the cylinder. A smooth landing will cause these two linkages to have excess vibrations. So excess vibration will cause the internal structure of the shimi damper to just to create some fine cracks, and these fine cracks will cause in one of the landings that the shimi damper should be broken down, and the landing gear will be free to move and will cause the for example mainly the collapse of the landing gear on the during the landing rule. Besides, there are recommendations from the manufacturing company, or in fact the Boeing, for the maintenance personnel to have regular inspection of the shimi damper system and to make sure they are functioning properly and they are normally equipped with the or supplied with the lubricant oil, just to make sure they are functioning as expected. It's also important to note that how much the piston should be extended from the cylinder in the main shock strut or shock absorbing part of the main and nose landing gear. To have the piston excessively extended from the cylinder is not a recommended procedure, and it will cause damage to the landing gear, mostly during the landings. So it is based on the temperature. So the maintenance personnel, they have a scale based on the temperature. They know how much the piston should be extended from the cylinder to have a normal operations. Like other units of the aircraft, the landing gears should have the proper servicing and testing, in fact, during the cycle that we are using them. So mainly there are some procedures with the maintenance personnel follow to lubricate the landing gear system. All movable, for example, parts of the landing gear should be properly lubricated. So it's also based on the maintenance just procedures that they are lubricating those movable parts of the landing gear with proper type of the grease, and they should be flexible enough not to damage, not to be worn during the retraction and extension cycles, because those parts will be moved, in fact. So thanks colleagues for watching the video. That was a rough overview of the landing gear system of Boeing 737 Classics, with some look on the basic concepts of the landing gears. In the next scenario, we will be talking about the brake system and including the auto brake system of Boeing 737 Classics and basic concepts. Thank you very much for watching video. Leave your comments and any question if you have in the comment box of this video. Time available, I will read and answer all those to you. Thank you.